Hello everyone, today we'll be talking about ensuring reliability, exploring the Go Backend protocol in computer networks. I'm Sanjana Singh and let's proceed. Coming to the introduction, understanding the Go Backend protocol in computer networks. Introduction. In computer networks, ensuring reliable data commission is crucial for maintaining the integrity of communication. Go Backend protocol is one such method used for achieving this reliability. Importance of reliable data transmission in computer networks. Reliable data commission ensures the data reaches its destination accurately and in correct order, minimizing errors and ensuring efficient communication. Overview of data transmission. Brief overview of data transmission in computer networks. Data transmission involves sending data packets from a source to a destination over a network. Mention the potential issues like packet loss, corruption, and delay. During transmission, data packets may encounter issues such as packet loss, corruption due to noise or interference, and delays in delivery. So, the mention of potential issues like packet loss, corruption, and delay. During the transmission, data packets may encounter issues such as packet loss, corruption, due to noise or interference in and delays in delivery. So moving forward, we have need for reliable transmission. Importance of reliable transmission in ensuring data integrity. Reliable transmission ensures that data is delivered accurately and that in the order without loss or corruption. Discussion of on the impact of unreliable transmission on the network performances. Unreliable transmission can lead to data loss, retransmission, and decreased network performances, affecting the overall efficiency of communication. Coming to the introduction of Go Backend protocol. Definition of Go Backend protocol. Go Backend is a sliding window protocol used for reliable data transmission in computer networks. Explanation on its purpose in reliable transmission. The Go Backend protocol ensures that data packets are transmitted reliably and in correct order, even in the presence of errors or packet loss. So the Go Backend protocol ensures that data packets are transmitted reliably and in the order, even in the presence of errors or packet loss. Explanation on the basic principles of Go Backend protocol. The sender uh, transmits a window of packets and the receiver acknowledge the receipt of each packet. If an acknowledgement is not received for a packet within a specified time, the sender transmits all packets in the window. Overview of the sender and receiver roles in the protocol. The sender transmits package and manages the window, while the receiver receive the received packets and manages the buffer. So the overview of the sender and receiver roles in the protocol. The sender transmits packets and manages the window, while the receiver receives packets and manages the buffer. Sender's perspective. Detailed explanation of sender's action on Go Backend protocol. The sender maintains a window of packets to be transmitted and waits for acknowledgements from the receiver. If an acknowledgement is not received within the timeout period, the sender retransmits all packets in the window. Receiver's perspective. Detailed explanation and receiver's action in Go Backend protocol. The receiver's packets checks for errors and sends acknowledgement to the sender. If the packet is received out of order, it is discarded. Importance of sequence and Go Backend. We have sequence numbers are used to identify and order packets. They allow the users to detect and discard duplicate packets and reorder out of order packets. The sequence numbers are used to identify and order packets. They allow the receivers to detect and discard duplicate packets and reorder out of other ordered packets. Then we have advantages of Go Backend protocol. Highlighting the advantages of using Go Backend protocol for reliable data transmission. Simplicity. Go Backend protocol is relatively simple to implement and understand. Second one is efficiency. It allows for efficient use of network bandwidth by transmitting multiple packets before waiting for acknowledgement. Reliability, it ensures that data is transmitted reliably in the correct order. So again, we have three advantages: simplicity, efficiency, and reliability. Simplicity is go back and protocol is relatively simple to implement and understand. Efficiency, it allows the efficient use of network bandwidth by transmitting multiple packets before waiting for the acknowledgement. Reliability, it ensures that the data is transmitted reliable in the correct order. So moving forward, we have limitations of go back and discussion on the limitations of go back and protocol. Reduced efficiency over long distance or in high error environments. Go back and protocol may experience decreased efficiency in networks with long propagation delays or high error rates. Wasted bandwidth. In case of packet loss, go back and protocol may result in retransmitting packets unnecessarily, leading to wasted bandwidth. So the limitations are reduced efficiency over distance in higher order environments and the wasted bandwidth. Go back and protocol may experience decreased efficiency in networks with long propagation delays or high errors. So in cases of packet loss, go back and protocol may result in retransmitting packets unnecessarily, leading to the wasted bandwidth. So we have brief comparison between go backend and selective repeat protocols. Go backend retransmits all packets in the window upon detecting an error, while selective repeat only retransmits the affected packets. Selective repeat is more efficient in terms of bandwidth utilization but is more complex to implement compared to go backend. Selective repeat is more efficient in terms of bandwidth utilization. Moving forward, we have real world applications. For example, of real world applications of go back and protocol. Go back and protocol is used in various network technologies and protocols such as TCP, Transmission Control Protocol, for reliable data transmission over the internet. It is also used in satellite communication and wireless networks. So the go back and protocol is used in various network technologies and protocols such as TCP for reliable data transmission over the internet. It is also used in satellite communication and wireless networks. Now we have implementation consideration. Factors to consider when implementing go back and protocol: buffer size, window size, and timeout values. Proper sizing of senders and receiver buffers to accumulate packets and acknowledgements, determining the optical size of the transmission window based on network conditions and performance requirements, setting appropriate timeout values to detect and handle packet loss efficiently. Then we have the case study. Presentation of a case study demonstrating the use of go back and protocol in a specified network scenario. Description of the network setup and requirements. Implementation details and challenges faced. Evaluation of the protocol's performances and effectiveness in the given scenario. Last but not the least, we have the conclusion. Summary of key points discussed. Go back and protocol is a sliding window protocol used for reliable data transmission in computer networks. It ensures reliable transmission by retransmitting packets upon detecting errors or packet loss, while go back end protocol offers a simplicity and reliability. It may experience limitations in certain network conditions. So the key summary is go back and protocol is a sliding window protocol used for reliable data transmission in the computer networks. So that was all about go back and protocol. So thank you for watching.